are you all? I hope you all are doing well. I am Mr. Prithviraj. I am a class 9 physics teacher. As you all know, we have completed 2 chapters so far, and today we will discuss another new chapter, the most common one. You might have heard 3 laws of motion. Every action has equal and opposite reaction. Yes, that chapter we will read. You might have heard this particular rule or this particular law in lot of movies, from lot of seniors and all, right? So what exactly this law and where this law comes from which chapter this law like we have taken, these all things we will discuss in this following chapter. So what is this name of the chapter? Students, the name of the chapter is laws of motion. What it is? Laws of motion. Let's start. Students, I hope you people are following each and every steps which will keep you safe. Okay. So on that notion, let us start our complete chapter. What exactly do you mean by motion? In our previous classes we have discussed already, but again I would love to say you what exactly is motion. Students, whenever an object changes its position with respect to time, you will call it as motion. When I am standing over here, I am at rest, but my hands are moving continuously with respect to time, right? My mouth is moving, my expressions are changing. These all are examples of motion or movement, right? So if an object is moving from one point to other point, you will say that the object is moving, right? The object is moving. In the same way, in this particular topic, we will discuss what are the laws which are constituted with this particular motion. Okay. Let us talk about history, because we know that each and every topic is related with history, right? Somebody has done something, then from there we have taken something, right? This kind of. So first, a famous philosopher, you might have known his name, like you have heard so many times. His name is Aristotle. Yes, right? You will have heard his name? Yes. His name is Aristotle. So what Aristotle said, that he said an object is always at rest. Let me simplify. Suppose I am running, at some point I will be tired, and again I will be coming to my original position, that is rest position. So he thought that universally each and every object's existence is rest only. So no need of explanation. That's his philosophy. Okay. Later what? Galileo. Who, students? Galileo. What Galileo said? Galileo said that an object in motion will remain in motion until and unless it has been given external force. Let me simplify it. Suppose a body is moving in this direction. This body is moving in this particular direction. This body will continue to move until somebody comes and pushes it or stops it, right? If nobody stops, why that body will stop? It will continue to move if it is a non-living. Suppose for living, okay, he will tired and all that kind of things will be there. What about non-living things? If you leave that, it will continue to move unless and until somebody stops it. That's what Galileo said. And Galileo performed 2 experiments. What are those experiments? Let us see. Means the same experiment, but he has performed twice. First he took a surface which was plane surface. As you can see this tray, this is a plane surface. Suppose we will let's think this is a plane surface. When he rolled down a ball, what he did? He rolled down a ball. So what he has observed? He has observed that the ball is moving far away. The ball is moving far away. Then he took another surface which was slightly rough. He took another surface which was slightly As you can see, this is a rough surface. This is not as plain as previous surface. Now when he took ball from here, what he has observed? He has observed that the ball is moving less distance as we have taken in the previous experiment. In the previous experiment, what he has done? He has taken a plain surface. But in this experiment, what he is doing? He is taking it is uneven surface, which is not plain. So in both of the cases, what he found out? He found out that in first particular thing, the ball is moving much away, like it is going far away from the second experiment. So he concluded, if surface is plain, the body will move firmly, nicely, continuously, without any abstraction. Are you getting me? Yes, I hope. Next we have seen that Galileo did another experiment. What kind of experiment? He has taken slope kind of experiment. Let me show you that one also. So he has taken this kind of surface. Now he left a ball from here. While the ball is going down, what he observed that the ball is keeping up the pace. Means the pace is increasing, the speed is increasing. Again, when it is going back, it loses its speed. It stays here. Again, it is coming back. So while going down, it is increasing its speed because of gravity. Again, while going up, it is decreasing its speed again due to gravity. Right? So from here he concluded that if surface is inclined downward, then the motion will be what? Faster. If surface is what? Inclined upward, then the motion will be slowed down. This is the important thing he has observed. In next experiment, what he did? He kept the surface same. This surface he kept same, but he decreased the elevation little. As you can see, he decreased the elevation. Slope, at first it was like that, now he did like this. Okay, then what he observed? The ball is moving far away up to this. So what is observing that when you are decreasing slope, the ball is moving little bit far. If you are increasing slope more, the ball is going little bit less as compared to previous one. You can take an example of a ball, okay? Suppose let me throw this one. If I try to throw this in this way, it will go much away. If I try to throw it upward, you will see it will go straight up, but not that distance it will cover. But if you throw it obliquely like this, you can see it will cover a lot of distance. That's what you want to say. On the first experiment, what was happening? This particular thing was like this. Right? It was like that before. So in this particular point, you see this inclination is more. So it is moving up to this only. But while we are decreasing inclination and we are taking it far, you see it should have stopped here, but no, it is going all the way up to this. Why? Because inclination decreased. If inclination decreased, then the ball will go little bit far from the previous state. Are you getting my point, students? If in this particular notion, what we will do, he said that let me conduct this kind of experiment. What? He made the surface plane. Now he left the ball and he made the surface plane. Then what he assumed? There is no inclination. It is 0 degree. Yes? Here if you draw angle, this is 0 degree. Now the ball will move continuously forever. The ball will move continuously forever in the third state. First state, the body was much elevated, so the depth and height was equal, so the position was also equal, like the displacement was also equal. And next, the depth was same, but your elevation little bit decreased. So it traveled little bit far away. Now the elevation is 0. So it will move in, it will continue to move continuously, like it will continue to move forever. It won't stop. In no place it will stop. Okay students? In no place it will stop. This was the assumption of Galileo. This was the assumption of Galileo. But later we found out that in our 8th class we have read about what? Friction. Yes. A moving body, if it is moving in air also, it is exerting a type of friction. What is that friction is? What is that friction, students? That friction is called as your what? Drag. The friction provided by air. The friction provided by surface. So that is also kind of force. And because of that force, the object may stop. The object may stop. That is what our, what do you call? That is what our like new explanation. But according to Galileo, he assumed the condition that the world has no friction. Okay. If the world has no friction, then if you have left a ball like in this case, it will continue to move on this plane forever. Are you getting my point? Yes. Now you need to read from page number 31st to 32 thoroughly, point by point, line by line. If you will read that, you will get it. What I am trying to say you. Okay. Just listen my class and try to point out with your all like class papers, means your chapter subject which is given in your book. Okay. Next. So this kind of activities taken up by Sir Isaac Newton. Yes, the same person who on his head the apple fall and he gave 3 laws. We are doing jokes, right? If the apple would have instead of apple, if the tree would have fallen, we wouldn't have discussed physics. We will be free birds like that, right? Yes, the same person. His name is Sir Isaac Newton. Isaac Newton thought that let me take this particular clause from whom? From Galileo, and I will propose 3 new laws. And from there, first law originated. First law he generated. Who? Sir Isaac Newton. Let us discuss first law of motion. This was the brief history which we have spoken throughout the class. Now we will speak about the first law of motion provided by our whom? Famous scientist, Sir Isaac Newton. So let me write his name. First we are pronouncing his name as Sir because he is universal teacher. Then I will write his name Isaac Newton. Sir Isaac the most famous scientist. Okay, he proposed first law of motion. 3 laws of motion he proposed. Now we will discuss about first law of motion. What is first law of motion? According to him, every object will remain at rest or in a state of uniform motion unless compelled to change its state by the action of a net force. Very confusing statement, right? Let me write it. What is right? What is saying that? Let me change. Okay, I'll take this one. He said that every object will remain at rest or in a state of motion or in a state of uniform motion. Okay, uniform motion unless compelled to change its state. Unless compelled change its state by the action of a net force. Big thing I've written, right? You read it. What it is? Every object will remain at rest or in a state of uniform motion unless compelled to change its state by the action of a net force. Let me simplify it with a diagram. This body is at rest. You can see this one. I am writing. This body is at rest. It will rest, it will continue to stay at rest unless and until I am pushing it. Suppose I will push it in this direction. So it will move in that direction. If the body is at rest, it will continue to stay at rest unless and until I am going and pushing it. You can see your bike. If you won't start your bike, that won't start automatically. Right? You are getting my point? Okay. Now the next point what he included. If a body is moving, then it will moving. It will continue to move. If a body is moving, it will continue to be on the move unless and until you go and you stop it. Yes, you can do that as well. How? Suppose we will start a bike, we will start the accelerator, it will continue to move unless and until you apply brake. You are getting my point? So these two things you need to keep in your mind. A body will be staying at rest or a body will be continue to move. A body is moving continuously unless until it is affected by or it is compelled to change its state. State means if it was at rest, it is at rest state. If it is moving, it is at moving state. So it is compelled to change its state by the action of external force. Somebody comes and somebody moves it or somebody stops it. That's what your first law states. Again I am saying in a simple word you can remind this one. You must write this one. A body will move continuously. A body will move continuously or a body will remain at rest unless until external force is applied on it. Okay? A body is at rest, will remain at rest. A body at uniform motion will continue to be in the uniform motion unless until it is like exerted by an external force. Unless and until it is compelled by an external force. This is what first law of motion. Very easy. If your object is at rest, it will continue to be at rest unless and until you are pushing it. Suppose the book is kept over here. If I am moving it, it will move. It won't move until I am moving. Okay. If I am leaving the book, it will continue to fall down on the bench. Now bench is acting as a barrier. If bench is not there, then it would have gone to the ground. If ground is not there, if it will go continuously downward, it will continue to move unless and until somebody stops it. That's what our first law states. Now we will discuss a lot of things in the same law on our next particular part of this video. Until then, bye bye.